So you were supposed to combine carbon and chlorine. What? Oh, okay. Well, it'll be all right. It'll come back in a minute, hopefully. Okay. And you were supposed to use Lewis dots to find the most reasonable arrangement for a Lewis dot formula. So we had carbon that has 4 dots around it. Carbon has 4 Lewis dots. Chlorine, or electron dots actually, chlorine has 7 electron dots. Now chlorine and carbon both want to have 8 dots. Since chlorine has 7 now, if I just share 2 of them, that takes care of this chlorine's need or wanting to have 8 dots. Okay, it now has 8 because it has the 7 it started with, and then it has the extra one that it's sharing. But now carbon at this point has 5 electrons, but it wants to have 8. So we need more chlorines then to satisfy carbon's need for more electrons. So I put the chlorine down here and I share another electron between the 2 of them. And that gives this chlorine 8 again, but now this carbon has 6. We need some more. So if I share this electron here with this carbon's electron, notice I'm not breaking up the pairs of electrons. I'm only using the electrons that are by themselves. Okay? That takes care of this chlorine, and we're almost done with carbon. We need 1 more chlorine to take care of carbon's need for 8. Your drawing doesn't have to look exactly like mine. What matters is that you have a total of 4 chlorines, 7 dots around them, 1 carbon with 4 dots, and that you share them in this manner so that carbon ends up with a total of 8 electrons, and each chlorine has 8 electrons. So now that takes care of all these atoms. Okay? Now that's the starting place. This is the beginning. We still have to get to what it looks like once you put everything together. So once we squeeze all the electrons that are shared between the atoms, the carbon's going to end up with 1, 2, 3, 4 shared pairs around it. 1 pair, 2 pairs, 3 pairs, and 4 pairs. And those are all shared with a chlorine. And each chlorine has 1, 2, 3 unshared pairs, or lone pairs. And that's the final Lewis dot formula for this molecule. No. You just have to have this and some kind of indication that you're going from this drawing to this drawing. You can put 1 and 2, you can put an arrow, you can put them in boxes like cartoon strips, whatever you want to do, as long as you are showing me you go from this step to this step. Okay? Then you were asked to put together nitrogen and hydrogen. So nitrogen has 5 electron dots. Okay? Hydrogen only has 1, and it only needs 1 more. Each hydrogen needs 2 electrons and only 2 electrons. Nitrogen, on the other hand, needs to have 8. So if we share these 2, that takes care of hydrogen, but nitrogen needs 2 more, so we're going to need 2 more hydrogens. and share these electrons and these electrons, and that's going to give all the hydrogens the 2 electrons they want, and it's going to give the nitrogen the 8 electrons it wants to have to be as stable as it can be. Putting it all together then, nitrogen has a lone pair at the top. It has a shared pair on each of the 4 sides, or each of the remaining 3 of 4 sides, and then hydrogens are what those electrons are being shared with. It doesn't matter if the lone pair is up here, if it's over here or down here. What matters is that you have a lone pair and 3 shared pairs with hydrogens attached. Alright, and then I ask you to put together carbon and 2 oxygens. So carbon has, same as we started with up here, has 4 electron dots to start with. Electron dot notation for carbon has 4 dots, 1 on each of the 4 sides. Oxygen has 6. 1, 2, 3, 4, and this is the way you write the electron dot notation. You put 1 dot on each of the 4 sides and pair up as needed. So I need to have 2 more electrons here paired up in order to get to 6. So another oxygen here, 2, 3, 4, and pair up as needed. Alright, to get the 2 oxygens and the carbon to have 8 electrons through sharing, we'll have to double bond between the oxygen and carbon, between the oxygen and both carbons actually. So the double bond is shown as 4 electrons in a kind of box arrangement. And the lone pairs on any 2 of the remaining 3 sides on the oxygens. The lone pairs on any 2 of the remaining 4 sides of the oxygen. And so that's the Lewis dot formula for a molecule of carbon dioxide. So you begin here and you end here.